So we've talked about some vector fields, and we saw that they could not represent electric fields. They were not physically viable electric fields. So let's now think about the electric field produced by a point particle of charge, say capital Q, right? We already know what the field looks like, and we'll consider its divergence. So right near the field, the electric field lines are radial, right out of the page as well, and they get smaller as 1 over the distance squared. So they look something like this. And the mathematical expression is, of course, the constant times the charge. Then we have an r hat over r squared. So we know that this is a physical electric field, and we can see from the drawing that the field is diverging away. Right, the electric field lines diverge radially away from the source of the charge. And we know that the differential version of Gauss's law says that the divergence of the electric field is the charge density divided by epsilon naught. So let's calculate the divergence here, and let's see what happens. So we should be able to get this quantity. So we know that the divergence of the electric field is, right, we have constants here, we'll just pull them out. And then we have the operator in these coordinates, which is, as we've seen before, 1 over r squared times the partial with respect to r of r squared times the radial component, which this field only has a radial component. So it looks like that. And that is Q over 4 pi epsilon naught times 1 over r squared times, right, r squared times ER. ER is just, well, it's the constant times 1 over r squared. We already wrote that part down. So we have r squared divided by r squared, so that's just 1. And so it looks like, sorry, there's a partial here, partial with respect to r of a constant. And so that looks like we get 0. And that's in tension with the fact that we know that the charge density is not everywhere 0. So here, at least at r equals 0, right, at r equals 0, rho E is not equal to 0. And so our expression should capture that. And so what we need, something went wrong here. The divergence of E involves a function which can be 0 everywhere because the charge density is 0 everywhere else, but not at r equals 0. And so there must be something strange. We must have made some mistake. And if we notice, we are dividing by r squared, and at r equals 0, 1 over r squared is equal to infinity. Right, so we notice that ER is approaching infinity as r approaches 0. And so we made an illegitimate move by dividing by 0. And so we need to figure out how to fix this such that everything is consistent.